Good morning. Welcome to the BEE course. Today we will discuss numerical problems on Ohm's law and Kirchhoff's laws. So I'll start with a quick statement of Ohm's law and also Kirchhoff's laws. Ohm's law states that the current through a conductor is directly proportional to the potential drop across it, or conversely, the voltage drop across any conductor is directly proportional to the current flowing in the conductor. And the Kirchhoff's laws states that the algebraic sum of currents at any node in an electrical network is equal to 0. Whereas Kirchhoff's voltage law states that the sum of voltage drops across all the elements in a mesh is equal to 0. So this is Ohm's law applicable for a single conductor. This is KCL, which is applicable to the currents at any nodes, and this is KVL, which is applicable to any mesh in an electrical circuit. Now we will try to solve simple problems on this one. So a quick recap, see here. See, determine the value of currents in this circuit. You can easily apply KCL. How many nodes are there? There is only one node here. So incoming currents is equal to outgoing currents, right? So if I start applying KCL here, how many incoming currents are there? 1 ampere, right? This is incoming current. Outgoing currents, 2 currents are there. What are they? One is 3 ampere, the other one is unknown. This is I. So what is I? 1 minus 3, it is minus 2 ampere. So the circuit is minus 2 ampere. Okay. So in today's class, we'll start applying Ohm's law and also Kirchhoff's laws. Predominantly, we try for Kirchhoff's laws for determining the response in a circuit. Now, if we start this one, see, this is a simple network. We are supposed to determine the current and the terminal voltage of the current source, and also determine the power which is dissipated in the 2 ohms resistor. So here we will employ Ohm's law for solving or for analyzing the circuits. Okay. If you carefully see, this current, you don't know this current, but it is flowing in both of these resistors, right? So it is flowing through 2 ohms, it is also flowing through 4 ohms. So here there will be a potential drop which is equal to I into 2, whereas here there will be a potential drop of I into 4. Right, because Ohm's law states that potential drop is equal to I into R. R has been given as 2 ohms, here it is given as 4 ohms, so it will be V is equal to I into 4. But they have mentioned that this is particularly equal to 8 volts, isn't it? So in that case, what is the value of I? It is 8 by 4, it is going to be 2 amperes. So the current which is flowing in the circuit is now 2 amperes. So 2 into 4, it is 8 volts it is creating here, and here it will be creating 2 into 2, it is 4 volts it is creating the drop. So now I will redraw the circuit now. See, you can go through this, but for me, I am directly writing. So this is of 2 amperes, and here it is creating 4 volts voltage drop, and here it is creating 8 volts voltage drop, isn't it? Now what they are asking, find the value of the current and terminal voltage of the voltage source. See, the current which is flowing is 2 amperes. Now let us apply KVL here. If I start applying KVL here, see, I don't know what is the voltage here. Let it be V. I'll start from top left here in this mesh. How many elements are there? 3 elements are there. 1, 2, and 3. The sum of voltage drops is 0, right? So if I start from here, see, this is, I'm moving from plus to minus, so it is plus 4. Again, I am moving from plus to minus, it is plus 8. Here I am moving from minus to plus, so minus V is equal to 0. So 12 minus V is equal to 0, it is V is equal to 12 volts. So the potential drop across this one is 12 volts. Understood? So applying KCL, what is 4 volts plus 8 volts? It is 12 volts, right? And the current in the source is 2 amperes. And the last question there is, determine the power that is dissipated in 2 ohms resistor. See, where is the 2 ohms resistor? This is the 2 ohms resistor. What is the power which is dissipating there? It is P is equal to V into I. Or I can write it as I square. What is the current flowing in this one? It is 2 amperes. 2 square into, what is the resistance here? 2. So it is 2 square into 2, it is 8 watts. Understood? Now, see, second question. 3 bulbs are connected in series, as shown in the figure. What is the current and voltage across each bulb? Right, see, this is the current which is flowing in the circuit, I, isn't it? So how much drop it will be creating here? V1. Here it is creating V2, and here it is creating V3. Am I clear? Right. So V1, V2 and V3 are the voltage drops which are created across this one. And see here, I'll take the polarities in this way. So if I start applying KVL, what I'll be getting? If I start applying KVL, what I'll be getting? See here, I will start from the top left. See, plus to minus V1, plus to minus V2, plus to minus V3. And here minus to plus 100 volts, right? So V1 plus V2 plus V3 minus 100 is equal to 0. Isn't it? So it is V1 plus V2 plus V3 is equal to 100 volts. This is the first thing which I'll be getting. Right. And if you carefully see, all the three things are in common. Isn't it? See, if I take this as IR1 plus IR2, let the resistance be R1, R2 and R3. What is this? 100 volts, right? So if I take I common, R1 plus R2 plus R3 is equal to 100, isn't it? Right. This is the first equation. In the second equation, if you carefully see how we can write the second equation. See, the power which is dissipated in this one is given as 30 watts. What is the power which is dissipated in the first resistor? It can be taken as I square R1. Right. It is 30. Similarly, second one I square R2. It is 40. Third one I square R3. It is 50. So if I add them and take I square as common, I will get I square. How much it is? 30 plus 40 plus 50. How much? It is 120. See, two equations I do have. Right. If I divide this equation with this equation, see, what I will be getting, this is cancel, I square by I, it is I is equal to 1.2 amperes. See how simple it is. I is equal to 1.2. So if I substitute here, I is equal to 1.2. So I will be getting R1 also. See, this is the total power 120, V is equal to 100. I think I is equal to 1.2. So once I get 1.2, the next thing is what I must do? I can calculate voltage across each bulb. See, in this one, what is the power here in this particular one? It is 30, right? P1 is equal to 30. It is I square R1. Or I can also write it as V1 into I. The voltage across it we have seen earlier also. It is V1 into I, isn't it? So what is V1? P1 by I. What is P1? 30 by 1.2. So it is 2.5 volts. For next one, 40 by 1.2. Sorry, 30, it is 25 volts, right? 25. 33.3. Next is 41.67. Like this. Understand? So this is the easiest way how we can employ KCL and KVL. See, this third question, write network equations using Kirchhoff's laws. Very simple one. See, if you see the network here, how many loops are there? 2 loops are there, loop 1 and loop 2. I'll take this one as a node A. Okay, so he is asking us to write only network equations, right? So I'll start with loop 1. So you are supposed to write two loop equations and one node equation. Loop equations using KVL. So in this loop equation, say in this loop 1, how many elements are there? 4 elements, 2 voltage sources and 2 resistors. 2 resistors and 2 voltage sources, right? I'll take the potentials like this. V1, this is V2, this is V3. And I'll be starting from top left, moving in this fashion. See, this is plus to minus. This is V1, plus to minus, it is plus V2. It is also moving from plus to minus, plus E2. But here I am going from minus to plus, right? So minus E1. V1 plus V2 plus E2 minus E1 is equal to 0. This is the equation. Whereas for loop 2, right? So here, this is plus to minus, this is also plus to minus, but here it is minus to plus, here also it is minus to plus. So these two will become positive, these two will become negative. V3 plus E3, E2 and V2 will be taken as negative. Understood? And next, node 1 or node A, or I'll take it as node 1. How many currents are there? I'll take this one as I1, I'll take this one as I2, I'll take this one as I3. Incoming currents is equal to outgoing currents. So I1 is equal to I2 plus I3. Or otherwise, incoming currents should be taken as positive, outgoing currents will be considered as negative. So I1 plus minus I2 plus minus I3 is equal to 0. If I rewrite it, I will get I1 is equal to I2 plus I3. Understood? This is the way how we write the equations using KCL and KVL. Okay, so I hope that now you are able to apply Kirchhoff's laws for writing network equations, and also I hope that you can apply them for determining the response in simple circuits. So I have given you lecture level practice questions. Try to solve this at home, and we will also discuss the same in the class tomorrow. Okay, so thank you. We'll meet again in the next class.